Friends and friends, welcome to my YouTube channel. Today I am going to discuss deflection of beam one derivation. Derivation is slope cantilever beam with UDL in entire span. So slope and deflections will find in the cantilever beam where entire span is UDL. So cantilever beam is one end free, one end fixed, other end is free. So what is the boundary conditions here we will get? Suppose at point A, if you see the deflection, y deflection will be 0. And if you see the slope, this also will be 0 when x equal to L, because you are considering x equal to 0, x equal to L. Left side x equal to 0, right side x equal to L. The right side x equal to 0, left side will be the L. So span will be L meter. Okay. So boundary conditions will be at B, x equal to 0 when length will be 0, deflections will be maximum. Deflections will be maximum. At free in deflections will be maximum. So now we are going to derive the slope and deflection. So before this we need the bending moment. If we will take one section xx, we will take one section xx. xx, what is bending moment about xx? So mxx about xx. So this is the UDL. So W into x. What will be there? W into x by 2. Now, what is the sign? See here, I am taking from right side. Right side, this is clockwise. Clockwise will be negative. So sign will be negative. Listen again. This is right side we are taking. About xx bending moment, this rotation is clockwise. So what is nothing but W into x by 2 half distance. Okay. So this is the bending moment about xx. Now we know the bending moment equation. Now we know that bending moment equation, what is m is equal to EI, E young modulus, I is moment of inertia, d square y by dx square. This is the bending moment equation. Now bending moment equation, this will substitute here and will integrate. So what is the bending moment equation? So right here, this part here, EI d square y by dx square equal to minus wx square by 2. This is the, we substituted the bending moment equation. This what bending moment equations we have our. Now we will integrate both sides. Integrating both side. Okay, both sides. So what is the integrations here? EI, take EI outside. EI d square y by dx square equal to minus w by 2 will take outside x square dx. So integrations will be here. EI, it will come dy by dx. So how this coming I will tell now. W by 2 x cube by 3 plus some constant c1. So d square y by dx square, see here. So this we can write dy by dx, then dy by dx. So d square y by dx square. So integration differentiation is always reverse, inversely proportional. So if you take the integrations, it will come dy by dx. Again, dy by dx integrations will take na, you can write d by dx and y. If you will integrate y, so this again integrations will come y. So okay, so this integrations is here and dy by dx integration is y. So once we'll do that, you have to remember. Okay. Okay. So now we'll apply the boundary conditions here. Now we'll apply the boundary conditions here. Okay. So now we got the equation wx cube plus c1. Give equation number. This you give equations number. This you give the equations number 1. Okay. This gives the equations number 1. So now we'll apply the boundary conditions here. To find the C1, we'll make dy by dx equal to 0. Where dy by dx equal to 0, that means slope will be 0 when x equal to L. When x equal to L, dy by dx will be 0. Substitute this in equations 1. Substitute this boundary condition in equation 1. So what we'll get here? EI 0 is equal to minus W by 2 x, that means 6 you take. 3 2 is 6, x cube na L cube by 8 plus C1. So C1 equal to what we'll get? WL cube by 48. Yes, WL cube by, now what is that? X square by 3. You put x equal to L cube by 8. WX square by 2. Just 1 minute. So WX square by 2 will integrate now, minus W by 2 x cube by 3, correct? Plus C1. You put x equal to L by 2 now there. X equal to L. X equal to L, no? So here will come L cube. L cube by 6. What is C1 is equal to? W by 6 L cube. W by 6 L cube, we got C1. Now substitute C1 in equation 1. Substitute C1 in equations 1. What is equations 1 here? EI dy by dx minus W by 2 x cube by, okay, 6 write directly. So W by 6 x cube plus W L cube by 6. This is the equations of the slope. Slope equations we know now. What is slope equations now here? Dy by dx, W by 6 x cube, W L cube by 6. This we got the, this you can write, this is the slope equation. This right slope equations. Give the equations number 2. Slope equations, no? This is slope equation, write the equation number 2. Now, where will be the maximum slope? Maximum slope will be when x equal to 0. So to get maximum slope, put x equal to 0 in equation 2. In equations 2. So what is equations 2 here? EI, that is called slope dy by dx, this will be maximum when x equal to 0. So W L cube by 6. Now what is the maximum slope here? Dy by dx maximum, that is also known as theta b, will be W L cube by 6. This EI will come here. This is EI. So this is the maximum slope we got now. What we got this one? Maximum slope we know now. We know the maximum slope. So WL cube by 6 EI. We got the maximum slope at point B. So okay, now we'll integrate again because we need the deflection. So we integrate equation 2. Integrate equations 2. Both side, okay, right? Both sides. So what will be the integrations now? To EI, one time I am writing EI integrations of dy by dx equal to minus w by 6 outside x cube dx plus w L cube by 6 dx. So what will the integrations here? EI y dy by dx integrations y is equal to minus w by 6 outside x power 4 by 4. This is the integration plus w L cube by 6 dx integration is x plus some constant C2. Some constant C2. This will give equations number 3. This give the equations number 3. So we integrated now. Now we need C2 value. Again C2 value will substitute here. We'll get the deflection equations. Okay. So now what we'll do? Another boundary conditions will apply. So we'll write this side now. So this part is over. Now what we have to do? Y will be 0. When y will be 0, deflections will be 0 when x equal to L. When x equal to L, y will be 0. That is called deflections will be 0. Substitute in equation 3. Substitute in equations 3. So what will be the here equations will come? EI 0 equal to, what is x equal to L? So minus w by 24 L power 4 plus WL cube by 6 into L plus some constant C2. So if you will solve here, C2 will come. How much C2 will come here? If you will solve this, so x equal to L, y equal to 0. So C2 is coming minus W L power 4 8 minus W L power 4 by 8. If you will subtract, C2 is equal to, this will become plus, this minus. If you will this side 0, if you will bring this, you will solve now C2, you will get this one. Now substitute C2 in equation 3. Equation 3. So what is equation 3 here? This one. So we will write here EI y equal to minus W by multiply 24, 6 was a 24, x4 plus x4 plus WL cube by 6, WL cube by 6 x minus WL power 4 by 8. This we got what equation? This we got deflection equation. This is known as, this equation is known as deflection equation. This we know the deflection equations. Give equations number 4. Give equations number 4. This is the deflection equations. What is deflection equations we got? Y minus W x power 4 by 24 plus W L cube x 6 minus W L power 4 by 8. Now what we'll do? When we'll get the maximum deflection? Maximum deflection when x equal to 0. So we'll write now there. So to get the maximum deflection, we'll write the conditions now. To get the maximum deflection, substitute x equal to 0. Then y becomes y maximum. So we will substitute in equation 2. This will substitute in equation 4. Substitute in equations 4. So what is equations 4? EI, that y becomes y maximum deflection will be maximum when x equal to 0. So this 0, what will get finally? Minus W L power 4 by 8. Now y maximum equal to minus W L power 4 by 8 EI. This is got the deflection equations. Minus 8. This is 8. Write nicely. This is 8. So this we got what is? Maximum deflection. Maximum this we know the maximum deflection. So WL cube by WL power 4 by 8EI. Now if total load will be there, sometimes questions like they will give total load. Total load the symbol will be capital W. If capital W is total load, then if you will change the Y maximum formula, Y maximum is equal to nothing but, so capital W is equal to W into L. So it will come minus WL cube by 8 EI. When this is the capital W. When this is the capital W. Okay, this you have to change. So here, if you will deflections also will change. This is small w, put the WL square by 6 EI. So where W is load, total load. This is nothing but total load. This nothing but, this W is nothing but total load. This total load is nothing but small w into L. So this way we can WL cube by 8 EI, then this will be WL square by 6 EI. So this way we can calculate the slope and deflections. Okay. Okay students, watch this video, subscribe the channels. Thank you.